ride, you guys. Okay, here we go. So, today's day 3, 5, 18. We are recording. Common Core Standard is polynomial graphs. Alright? So, what we're going to do is, first of all, if we're going to graph this without a calculator, okay, and we can do this. We can graph it without a calculator, and I want us to learn how to do it without a calculator. And we'll look at it on the calculator afterwards. But first of all, if we factor it, we get an x times an x squared minus 9, right? And if we factor it again, I get an x plus 3, x minus 3, okay? Now, we know it's going to have 3 answers, and the 3 answers are the zeros. We know it's going to have 3 answers, and the 3 answers are going to be the zeros. So to find the zeros, we're going to go ahead and have set it equal to 0, x equals 0, set it equal to 0, 0 equals x plus 3, set it equal to 0, and 0 equals x minus 3, right? So we're just looking for the 3 zeros. We've done this before. So one 0 is x equals 0, another 0 is negative 3, and another 0 is 3. Since these are real numbers, they're also x-intercepts. Okay? Since these are real numbers, these are also x-intercepts. Okay, so if there's zeros and they're real numbers, they're x-intercepts. We know the graph looks like this. We'll have a 0 at 0. We'll have a 0 at negative 3. And we'll have a 0 at positive. Okay, now, I know with polynomials, they're curvy, right? We've seen that before. They're like, whoop, right? And so I know my polynomial has to go through these 3 points. It has to, right? It's got to go up and through and up and through. Now, it could either go this way. Now, watch the thing. Everybody watching? It could either go this way, right? Or it could go this way. Watch my finger. Because x cubed is positive, it has to end going towards positive infinity. This is a positive x cubed, so its end behavior, it's called end behavior, is going to have to be like this. Has to. That's a positive x cubed, so it must end going towards positive infinity. So I know the graph must look something like this. Now that's not a perfect picture of it, but it's good enough. And if you were to take a look at it on the calculator, that's exactly what it looks like. I didn't give you any y values. I don't want the y values. I just want you to see how the graph works, okay? That's definitely how it works. Now let's talk about end behavior. Okay, end behavior. Okay, so as end behavior. So what's happening here is for end behavior? It's going to, we're going to say x, we're going to say it's approaching infinity, right? And end behavior, it's going to infinity, right? It's going off to, like Buzz Lightyear, going off to infinity beyond. See this graph? It's taken off to infinity, right? So as x gets bigger, y gets bigger. As x gets bigger, y gets bigger, okay? End behavior here, it's going down to negative infinity, right? Right? As x gets smaller, more negative, it goes to negative infinity. Now, they don't always work out like this, but in this case, end behavior, this one's going down forever. End means going to the end. And as it goes to the end, it's going to negative infinity. End means going to the end. And as it's going off towards positive infinity. Does that seem pretty easy? Okay. Good. Let's look at number 2, okay? So number 2, it says without a calculator, okay? Without a calculator, we can do this without a calculator, we can. So first of all, let's find the zeros, okay? Let's find the zeros first. So I set it equal to 0, negative x cubed plus 2x squared plus 8x, okay? And I need to somehow factor this, okay? Now, personally for me, I do not like factoring with a negative in front. I don't. So the easiest way to get rid of it is just multiply everything by a negative, because that is going to change it, right? I do not like to factor with a negative. You can be done. I don't like to. So what I do, just because I do not like negatives there, is I'm going to multiply everything through by a negative 1. So I'm just going to multiply by a negative 1. It just makes it easy for me to factor. Okay, so then I'll have a 0 equals a positive x cubed minus the 2x squared minus an 8x. And then I think I can factor this, okay? It's easy for me to factor. Yes, you can do it without doing this step, but it's more difficult. So at this point, I recognize that it has a common multiple of x. So I'll take out a common x, an x squared minus a 2x minus an 8, okay? Just common factor out the x. And once the x is out, I go, oh, wait a minute, I know the multiples of 8. The multiples of 8 that make a negative 2 is going to be a negative 4 and a positive 2. So I'm going to go, okay, I can do this. X times x minus 4, x plus 2, right? And again, without a calculator, we're doing a pretty good job of graphing this without a calculator. We can get one answer of one of the zeros is x equals 0. Another zero is x equals 4. And the other 0 is x equals negative 2, right? And then I'm just going to put those values on the x-axis because they are zeros, but they're also x-intercepts. So I'll put an x-intercept of 0. I'll go 1, 2 to negative 2. And I'll go 1, 2, 3, 4 to 4. Okay, how am I doing? So far, so good? Now, I know it's going to be curvy. It's going to be curvy just like the first one. It's going to have the same shape. But this one's going to have different end behavior. Because of the negative x cubed, it's going to have to finish going down. Because of the negative x cubed, because of the first term, because of the biggest degree, tells you which way it's going to finish. It's going to finish down. So this one's going to finish the other way. It's going to go like this and finish going down. I know that because this is a negative right here. So I know it has to finish going down. So I'm going to go ahead and just graph it in. So it looks something like this. Here it is. Okay. Now, we did this without a calculator. It really wasn't that difficult, was it? So first of all, let's talk about local max and local min. So let's describe them. So this would be my local min. Now we call it a local min, not an absolute min, because the absolute minimum is all the way down to negative infinity, right? I mean the ultimate minimum's all the way down to negative infinity, right? But this is called a local min because it's at the very bottom hill. So local min is right there. That's my local min. Okay? My local max is right here. That's my local max. Can't be my complete max because this graph is going off to infinity. I mean, the maximum, the very maximum of this graph is off at infinity. So that's why we call that a local max, okay? We've got our x-intercepts. We already know those, okay? And the y-intercept. Where's my y-intercept? It's right there at 0, okay? So my y-intercept, yes, is at, so my y-intercept is at 0, 0. End behavior, it's going to negative infinity, right? End behavior, it's going off to positive infinity, okay? So we'll say as x gets bigger, y gets smaller. As x gets bigger, y gets smaller. As x gets smaller, y gets bigger. I mean, if x gets bigger and bigger and bigger, this is going down, right? As x gets more negative, it's going up, okay? Not too bad? Okay. Ready to turn the page? All right, so same thing. Now this time it says with a calculator. So this one won't factor. So we're actually going to use a calculator. So before anything, I'm going to at least think about my window. A standard window, and I don't know how big this is, but a standard window is normally negative 10 to 10, and the y's will go negative 10 to 10. That's my standard window. And then if we all of a sudden, this is my window, if we need to adjust our window, we will. Okay, so I'm going to go to my window, and I'm just going to go to a standard window. I'm going to go negative 10 to 10, steps by 1, scales by 1, negative 10 to 10, right? And then if I put in my equation this time clear, I'll put in my, am I going too fast? Am I going too fast? Bailey, okay. Am I going too fast? Am I all right? X cubed minus 7x squared plus 6x minus 5, right? Okay. So I got it all typed in, and I'm going to push graph, Okay, now, here's what I have. Here's what I have. Something's going on down here, but I can't see it. So I'm going to adjust my window. I need to go further down, right? Does that make sense? I mean, something's going on around here somewhere, but I can't see it. It's too far down, so I'm going to adjust my window. I need my Y minimum more. I need to make my Y minimum more, so I'm going to go to my window, and I'm at a negative 10 for my Y minimum. Let's try negative 20. I don't know. Negative 20 maybe? Still not far enough down, right? So I'll make another adjustment. I want to go more negative on my Y min, so I go to my window, and let's make it maybe negative 30, right? Okay. Ah, there we go, okay. Did you guys get that? Did you guys get that? So now, so let's take a look at what we have. It's about 1, 2, 3, 4, 5, almost 6, right? 1, 2, 3, 4, 5, 6, about 6. Okay. Let's see some of the things we know. So my y-intercept, I know my y-intercept has to be negative 5. My y-intercept must be, so I know for sure y-intercept has to be at 0, negative 5, right? But what I don't know is my local mins, my local maxes, right? So let's see if we can remember how to do this. So if I want to find this, you watching? If I want to find the value of this point, that's a max, right?
Yes.
So I can go to second, calculate, maximum. Remember how we did that?
Yeah.
And I'm going to go ahead and go left bound, enter, and I'm going to go right bound, enter, and then there it is, about 0.47, about 0.48. So my max is about 0.48, comma, about negative 3.6. My minimum is way down there. So again, I'm going to go to second, calculate, right? And I'm going to go to my minimum, right? And left bound. So I'm going to take my cursor way over here, right? Enter. Cursor way over here. Enter. Guess. I don't really care. And here's my minimum. My minimum is at about 4.2 and negative 29 point, I think it's 2, isn't it? Okay. So now I'm ready to graph it. I got a pretty good picture on my calculator, right? So I kind of know what it looks like. So I know at least to get down to, I'm going to go like maybe negative 10, negative 20, negative 30, right? And I can plot my points. I've got right here's my y-intercept at negative 5. I've got my x-intercept at about 6. My maximum is about point, so if I go 1, 2, 3, 4, about 0.5 and about 3.6 might be about, I'm guesstimating about there. It doesn't have to be perfect. My minimum is about 1, 2, 3, 4.2, and about negative 29 is right about there. And I'm just going to sketch it in. It's going to look something like this. Not perfect, but good enough, right? There it is. And that was not too bad. Okay, and stop.